Okay. Sure. Okay, everybody sees the white page?
Yes.
Okay. So, so the function you saw, it was a special form of this function. X transpose A X plus, for example, A transpose X plus C, where A is equal to A transpose. Okay, so A is symmetric. Now, let's write this each term. What is A transpose X? A transpose X is A1 X1 plus A2 X2 AN XN. Okay. So what is the derivative of A transpose X with respect to Xi?
AI.
AI, right? So then the gradient of A transpose X is just A1, A2 to AN, which is A, right?
Yeah.
Does that make sense?
Yes.
Okay. Any questions at this point? Recall that the gradient of a function is just the partial derivatives. So df dx1 to df dxn. Any questions so far?
It's clear.
Okay. So now let's get to this to the quadratic part. What is X transpose AX? Essentially, it is this. Okay. So if you write this down, if you expand this, you can write this in two terms. So I from 1 to n xi aii squared plus 2 oh no, not 2 plus I from 1 to n and j for all the j's that are not equal to I xi xj Aij. Okay. So let's look at the three-dimensional case example. It means that X transpose AX is X. Okay, sorry, there's a mistake here, first of all. What is the mistake?
So are you trying, so is the summand above example, are you removing the diagonal from the entire summation?
Yeah, well, I'm looking at the diagonal separately, and then I look at the off-diagonal terms.
I see.
But there's a problem here. What is the problem?
Should the xi have a square on it too?
Yes, the xi should have a square, the ai shouldn't have a square. So let me just do a 3x3 example. I think that will make everything super clear. It's always, I mean, in these cases, it's always useful to do a simple 3x3. 3 is typically illustrative. So you have x1, x2, x3, a11, a12, a13, a21, a22, a23, a31, a32, a33. x1, x2, x3. So this is x1, x2, x3. And then here you have a11, x1 plus a12, x2 plus a13, x3. And then here you have a21, x1, a22, x2 plus a23, x3. And then here you have a31, x1 plus a32, x2 plus a33, x3. Okay, and then if you do this multiplication, you can show that this is x1 square a11 plus x2 square a22 plus x3 square a33 plus 2 x1 x2 a12 plus 2 x1 x3 a13 plus 2 x1 x2 x3 a23. Note that we use the fact that A is equal to A transpose. That means, for example, that Aij is the same as Aji. Okay. Any questions? Okay. Okay. So this is supposed to be equal to X transpose AX. Okay. Now, what is the derivative of X transpose AX with respect to X1?
2x1a11 plus 2x2a12 plus 2x3a13.
Okay, let me just write it something more compact so we have room for doing something interesting. So it's 2a11 x1 plus 2a12 x2 plus 2a13 x3. What is dx transpose ax dx2?
2x2a22 plus 2a12 x1 plus 2a23 x3.
Okay, and I use the fact that aij is equal to aj1. And then finally, this is equal to a 31 x1 plus 2a 32 x2 plus 2a 3 x3. Okay, so this is just a 3x3 or 2x2. You could have done that easily, and just to show you how you can approach these problems if you're interested. So now, what are these, each of these terms? So essentially, we can write that that the gradient of x transpose ax, which is df, sorry, d x transpose ax to dx1, dx transpose ax dx2, dx transpose ax dx3. And this happens to be 2ax.
Oh, okay. That was very clear. That makes a lot of sense. Thank you so much.
Sure.
Thank you.
Sure. Any other questions? Comments?
Can I ask how important is it to be following all these mathematical steps? As in, do we have to be able to replicate that? Do we have to understand what's going on?
I suggest that you try to understand it and you try to replicate it at least once for yourself. But for the final project, for example, you won't need this. But to understand the concepts, it's useful to do it at least once. And in the next homework assignment, some of these may show up. In the third homework assignments, less. In the fourth, less. So it will be less. But in the next 1 or 2 homework assignments, some of these material may show up. But yeah.
And aside from the homeworks, will we be tested on these at all?
Let me see. Syllabus says no. So only on the homework assignments.
Okay, thank you.
Sure. Any questions?
Excuse me, at the end, we got a scalar value to AX.
What is A?
Oh, the matrix, the big matrix.
What is X?
Oh, yes, yeah, now I get it. It's a
No,
matrix.
let's say it so because it might be a question of somebody else too. That's why I'm asking. So A is a matrix, X is a vector, so AX is a vector. So 2AX is a vector. The gradient is always a vector. And it's just a partial derivative that you place in the entries of that vector. Okay?
Yes.
So yeah, I mean, if you have anything in that line, let me know, so just to clarify it. Yes? No questions? Okay, yes. Okay, so there are no questions. Then what we'll do is I will post a video lecture with lecture notes and an R code, and we will meet in an hour and a half. Well, can you speak your questions? Okay, page 17. Let's see. Yeah, why what? I mean, can you go over why? I need to understand the question. Okay. Okay. So what is this? This is the L2 norm. This was in one of the first lectures, video lectures, which is A transpose A. So the L2 norm of Y minus X is what? You can call this A now, and then this will be Y minus X beta transpose Y minus X beta. That makes sense? Okay, good. Great. Any other questions?
Professor, hello. Will you upload this recording just to go over it one more time?
Yeah, but I mean, I don't want you to go over it now. This will be.
Okay, of course.
Oh, yes.
Yeah, of course. Thank
you. Any other questions?